Picture this. You walk into a GM dealership in 1981 with your hard-earned money, ready to buy that new Camaro Z 28 you've been dreaming about, the one advertised with 190 horsepower. You drive it off the lot, and something feels wrong. Not catastrophically wrong, just off. The throttle response isn't crisp. The acceleration feels lazy. And when you finally take it to the track and run the numbers, you're down 25 horsepower from what the previous model year made with the exact same engine. Welcome to one of the quietest engineering disasters in automotive history. The golden age before the fall. Let's rewind to 1978-1979. GM is still king of the American automotive world. Sure, the muscle car era is technically over, emissions regulations have neutered the big blocks, and fuel economy is the new religion. But General Motors is still building some genuinely interesting performance cars. The Corvette, the Trans Am, the Camaro Z28, even the Monte Carlo SS, these cars represented what was left of American performance in a strangled regulatory environment. And here's the thing nobody talks about. The exhaust systems on these cars actually worked pretty damn well. GM's engineers, the guys who'd survived the horsepower wars of the 1960s and learned to extract performance from strangled emissions motors, they knew their stuff. They were running thick cast iron exhaust manifolds that had been refined through years of testing and real-world application. Cast iron manifolds. Let that sink in. These weren't sexy. Nobody wrote magazine articles celebrating their thermal properties, but they did something absolutely critical that most people never thought about. They retained heat in exactly the right way. See, an exhaust manifold isn't just a pipe to get gases out of your engine. It's a carefully engineered component that manages heat, controls back pressure, and influences scavenging, the process by which exhaust leaving one cylinder helps pull exhaust from another. GM's cast iron manifolds from this era were thick, heavy sons of guns. They weighed a ton, sure, but that weight was insulation. The thick walls kept the exhaust gases hot, which kept them moving fast, which kept cylinder scavenging efficient. The manifolds were designed with specific runner lengths and diameters that had been optimized through decades of development. They worked with the camshaft profiles, with the cylinder head port designs, with the entire breathing strategy of the engine. And the result? These late 70s GM performance engines made their rated power. Not impressive by 1968 standards, but honest power for their era. A 1979 Camaro Z28 with a 350 small block made 175 horsepower. Not much, but it was real usable power that showed up at the wheels when you needed it. Mechanics loved these manifolds because they didn't crack, didn't warp, and lasted basically forever. You could run that engine hard, heat cycle it a million times, and those cast iron manifolds just kept doing their job. There were GM trucks from the late 70s running around with 300,000 miles on the original exhaust manifolds, still sealed tight, still flowing properly. But wait, that was the problem, according to the new breed of executives taking over GM in the late 1970s. These manifolds weighed somewhere between 40 and 60 pounds, depending on the application. And to the accountants who were increasingly running the company, that was 40 to 60 pounds of cast iron they were buying, machining, and installing on every single vehicle. Multiply that by millions of units, and suddenly you're talking about real money. Oh, the accountants take over 1980. This is when everything changes, not just for exhaust manifolds, but for GM's entire engineering philosophy. Roger Smith becomes chairman and CEO, and he brings with him a Wall Street mentality that's going to reshape the company, and not in a good way. Smith is obsessed with quarterly profits, shareholder value, and cost per unit metrics. He's not a car guy. He's a finance guy who sees automobiles as widgets to be optimized for maximum profit extraction, and he's surrounded himself with people who think exactly the same way. The mandate comes down from the 14th floor. Reduce costs everywhere possible. Not through better efficiency, not through smarter engineering, but through simple material substitution and cost cutting. Engineering is told to find savings, and they're given targets that are basically impossible to meet without compromising the products. Here's where it gets interesting. Some middle manager in the powertrain division runs a cost analysis on exhaust manifolds. Cast iron manifolds cost, let's say, $25 per unit to produce when you factor in the raw material, the casting process, the machining, the quality control. But stamped steel manifolds? Those could be produced for maybe $8 per unit. Do the math. $17 savings per vehicle. Multiply that by 2 million vehicles per year. And you're talking about $34 million in annual savings. To an accountant, this looks like found money, free profit just sitting there, waiting to be captured. The engineering team pushes back. They know cast iron manifolds work. They know the thermal properties matter. They know that stamped steel manifolds, basically just sheet metal bent and welded into shape, won't retain heat the same way. They know the thinner material will warp, crack, and fail. They know the performance implications. But here's the thing about corporate culture in 1980 GM. Engineers don't get the final vote anymore. Finance does. And finance doesn't care about thermal dynamics or scavenging efficiency. They care about cost per unit and profit margins. There's a meeting. I've heard this story from 3 different people who were there, so I believe it's real, where an engineer actually puts together a presentation showing dyno results with cast iron versus stamped steel manifolds. Same engine, same tune, same everything, except the manifolds. The cast iron setup makes 175 horsepower. The stamped steel setup makes 152. 23 horsepower, gone, just from changing the manifolds. The finance guy running the meeting looks at this data and says, but customers can dyno test their cars, they won't know. And that's the end of the discussion. The decision is made. Stamped steel manifolds will be standard across most of the GM lineup, starting with the 1981 model year. The change nobody saw coming. The transition happens quietly. There's no press release, no technical bulletin, no mention in the sales literature. GM just starts bolting stamped steel exhaust manifolds onto engines that used to have cast iron. If you weren't looking for it, you'd never know the change happened. The new manifolds are manufactured by outside suppliers using a stamping process that's been around since the 1920s, but never applied to exhaust manifolds before. Flat steel sheets, maybe 16-gauge thickness, are cut to pattern, then formed in massive hydraulic presses that can apply thousands of tons of pressure. The metal gets bent, shaped, and folded into something that roughly approximates a manifold. Then the pieces are tack welded together at the seams, creating what looks like an exhaust manifold if you squint at it from a distance. It's faster, cheaper, and produces a lighter component. On paper, this looks like engineering genius. Lighter weight improves fuel economy by maybe 0.2 miles per gallon. Manufacturing costs drop from $25 per unit to $8. GM's purchasing department gets a bonus for negotiating such a sweet deal with the stamping suppliers. The quarterly earnings report looks fantastic. Shareholders are happy. Wall Street analysts praise GM's commitment to efficiency. But the thermal reality is disastrous, and anyone who understood exhaust dynamics could have predicted it. Stamped steel manifolds have walls that are maybe 1/8 the thickness of the old cast iron units. We're talking about metal that's thin enough you could probably puncture it with a screwdriver if you really wanted to. This means they heat up faster when you start the engine, which sounds good until you realize they also cool down faster, way faster. The exhaust gases passing through these thin-walled manifolds lose temperature much more rapidly than they did in cast iron. We're talking about temperature drops of 200, sometimes 300 degrees compared to the old setup. The gases that should be screaming out of your engine at 1200 degrees are down to 900 degrees by the time they hit the collector. Why does this matter? Because exhaust gas temperature directly affects velocity, and velocity affects everything downstream. Hot gases are less dense and move faster. It's basic physics. When your exhaust gases cool down rapidly in thin-walled manifolds, they slow down. The gas molecules pack tighter together, take up less space, move more sluggishly. When they slow down, the entire scavenging effect that helps pull exhaust from the cylinders becomes less efficient. And here's where it gets really technical. Scavenging is how modern engines breathe. When exhaust from one cylinder exits at high velocity, it creates a low pressure wave that helps pull exhaust from adjacent cylinders. It's like a suction effect. and it's critical for getting spent gases out and making room for fresh air and fuel. When scavenging efficiency drops, you get more exhaust gas remaining in the cylinders, called residual exhaust. That residual exhaust takes up space that should be filled with fresh mixture on the next intake stroke. Less air and fuel means less combustion, energy means less power. Simple as that. But it gets worse, and this is where GM's cost-cutting really shows its stupidity. The stamped steel manifolds also have different internal geometry than the cast iron units they're replacing. The manufacturing process doesn't allow for the same smooth internal surfaces or carefully designed runner lengths. In cast iron, you can cast complex shapes with smooth transitions, gradual bends, and optimal flow paths. Engineers spend months optimizing these shapes in flow benches and on dyno tests. With stamping, you're limited to what you can form from flat sheet metal and weld together. The result is sharp bends that create turbulence, willed seams that stick into the exhaust flow like speed bumps, and restrictive passages that increase back pressure. Every sharp corner is a place where exhaust flow separates and creates drag. Every weld bead is an obstruction. Every crude transition is wasted energy. The engineering team had warned about this. They'd done the testing. They documented the performance loss, but the decision had already been made in boardrooms where the only metrics that mattered were cost per unit and profit margins. GM rolls this out across nearly the entire lineup. The Camaro gets stamped manifolds. The Corvette gets stamped manifolds. The trucks get stamped manifolds. Even the Cadillac 5.8s get downgraded to stamped steel. The only exceptions are a few specialty applications where the performance loss would be too obvious to ignore. Things like the high-performance Corvettes still use tubular headers, and at first, nobody notices. Customers taking delivery of new 1981 models don't have a baseline for comparison. If you've never driven a 1980 model with the cast iron manifolds, you don't know what you're missing. The engine still starts, still runs, still moves the car down the road. It's just slower, less responsive, less eager to rev. Most customers chalk it up to emissions regulations or modern engineering compromises. They have no idea they're driving a deliberately neutered product. Horsepower vanishes into thin air, but the dyno doesn't lie. And by late 1981, performance shops and magazine testers are starting to notice something weird. New GM vehicles aren't making their rated horsepower, not even close. Car and Driver tests a 1981 Camaro Z28 and can't hit the claimed acceleration numbers. They figure it's a fluke, maybe a bad test car. Motor Trend has the same experience. Hot Rod magazine puts a bone-stock 1981 Corvette on the dyno and measures 153 rear-wheel horsepower when the engine is supposed to make 190 at the crank. Now, you expect drivetrain losses, figure 15 to 20% between the crankshaft and the rear wheels. But the math isn't adding up. These cars are underperforming by margins that can't be explained by normal variation. Independent shops start doing their own testing. A performance shop in Southern California gets curious and swaps a set of aftermarket headers onto a brand new 1981 Camaro. Just headers, nothing else changed. The car picks up 18 horsepower at the rear wheels. 18 horsepower from just replacing the exhaust manifolds. This is when people start reverse engineering what GM did. They pull off the stamped steel manifolds and compare them to the old cast iron units from 1979 and 1980 models. The differences are obvious once you know what you're looking for. The stamped steel manifolds are warping from heat cycles. After just a few thousand miles, you can see the distortion in the flanges where they mate to the cylinder heads. The gaskets are getting crushed unevenly, creating exhaust leaks. The thin metal is developing stress cracks at the weld seams. But the real killer is the thermal problem. Infrared temperature testing shows the stamped manifolds are running 200 degrees cooler than the cast iron units. That temperature drop translates directly into reduced exhaust gas velocity and compromised scavenging. Here's the really frustrating part. GM's own engineers knew this would happen. They'd tested it. They'd documented it. But the decision had been made at a level where engineering data didn't matter anymore. Warranty claims start flooding in. Exhaust leaks, cracked manifolds, broken studs. The stamped steel units are failing at rates the cast iron manifolds never approached. GM is saving money on production, but spending it on warranty repairs. And the performance loss isn't just a numbers game for magazine testers. Real customers are noticing. The truck guys are complaining that their new Silverados feel gutless compared to last year's model. Camaro owners are getting walked by Mustangs that used to be even matches. The Corvette, GM's flagship performance car, is slower than it should be. Mechanics discover the problem. The guys actually working on these cars every day, the mechanics in dealerships and independent shops, they're the ones who put the pieces together first. They're seeing the pattern before corporate GM wants to admit there's a problem. Jimmy Martinez runs a Chevrolet dealership in Phoenix. He's been selling Camaros since 1967, knows these cars inside and out. By mid-1982, he's getting customers coming back complaining about performance. One guy brings in his 1981 Z28 and parks it next to his friend's 1979 Z28. Same engine, same transmission, same rear-end ratio. The 79 car pulls on the 81 like it's got 50 more horsepower. Martinez puts both cars on his shop's chassis dyno. The 79 makes 138 rear-wheel horsepower. The 81 makes 114. 24 horsepower difference at the wheels, probably 30 at the cranks. From the exact same engine configuration, he starts investigating. Pulls the valve covers, identical. Checks the camshaft timing, identical. Looks at the carburetor, jetting, identical. Finally, he gets underneath and really examines the exhaust manifolds. That's when he sees it. The 81 car has these flimsy stamped steel manifolds that look like they were made in somebody's garage, while the 79 has those chunky cast iron units. He calls GM's tech support line, gets bounced around for 3 days, finally reaches an engineer who confirms, off the record, that yes, they switched to stamped steel manifolds to save costs, and yes, there's a performance penalty, but it's within acceptable parameters. Acceptable to who? Not to the customers who paid for a Z28 expecting Z28 performance. This story repeats itself in shops across the country. A mechanic in Detroit notices the pattern. A technician in Los Angeles figures it out. A performance shop owner in Atlanta documents it with before and after dyno sheets. The smoking gun evidence comes from GM's own warranty database, which starts showing alarming failure rates for exhaust manifolds on 1981 and newer vehicles. Cracked manifolds, warped flanges, broken mounting studs. The stamped steel units are failing at 3 times the rate of the cast iron manifolds they replaced. Dealers are caught in the middle. They're selling these cars, taking customer complaints, doing warranty repairs on GM's dime, but they can't fix the fundamental problem because the fundamental problem is a cost-cutting decision made in a boardroom in Detroit. Some dealers start getting creative. They're finding new old stock cast iron manifolds from 1979 and 1980 models and upgrading customer cars. GM Corporate gets wind of this and sends out a directive. Dealers are not authorized to retrofit previous generation parts, even if it solves the problem, even if customers are willing to pay for it. This is when mechanics and dealers start recommending aftermarket solutions. They can't put GM's old cast iron manifolds back on, but they can sell customers a set of headers or performance manifolds from companies like Hooker or Hedman. The aftermarket saves the day. The aftermarket industry sees opportunity in GM's disaster. Companies that make performance exhaust components suddenly have a massive new market. Every GM performance car from 1981 forward needs better manifolds just to make its stock horsepower. Hooker Headers runs advertisements in car magazines showing dyno results. A stock 1981 Camaro with GM's stamped manifolds makes 150 horsepower. The same car with Hooker Headers makes 173. Get back the horsepower GM took away becomes their tagline. Edelbrock develops a line of cast aluminum manifolds specifically for these applications. They're lighter than the old cast iron units but have the thermal mass and smooth internal passages to maintain exhaust gas velocity. They're not cheap. A set costs $300 in 1982 money, but they work. Hedman Headers goes a different route, offering budget-friendly tubular steel headers that are still way better than GM's stamped manifolds. They're selling these things as fast as they can make them. Here's the beautiful irony. GM switched to stamped steel manifolds to save $17 per vehicle. Now their customers are spending $300 to $500 to replace those manifolds with aftermarket units just to get back to baseline performance. And all that money is going to GM's competitors, strengthening the aftermarket industry while weakening customer loyalty to GM products. Performance shops make a killing. Installing headers becomes one of the most common modifications for GM vehicles. Shops that specialize in GM performance see their business boom. They're basically cleaning up GM's mess and getting paid handsomely for it. The real tragedy is that this is completely unnecessary. The old cast iron manifolds worked fine. They lasted forever, made good power, and customers were happy. GM created a problem that didn't exist, then forced their customers to pay aftermarket companies to fix it. And customers notice. They're not stupid. When you have to immediately spend $500 on exhaust components for your brand new car, just to make it perform like it should have from the factory, you start questioning your brand loyalty. Word gets around. GM dealerships start losing sales to Ford and Chrysler. Import brands like Toyota and Nissan start looking more attractive. Why buy a GM product that you know is gimped from the factory when you can buy a competitor's product that doesn't have these issues? The damage to GM's reputation is subtle but real. This isn't a recall-level disaster. The cars still run, still pass emissions, still serve as transportation. But among the enthusiast community, among the people who actually care about how their cars perform, GM has revealed something important. They're willing to sacrifice product quality for quarterly profit margins. The long-term consequences. The stamped manifold debacle is a turning point that nobody recognizes at the time. It's not dramatic enough to make headlines. There's no Ralph Nader writing exposés, no congressional hearing where executives get grilled on C-SPAN, no massive class action lawsuit that ends up in settlement checks showing up in mailboxes. No government intervention forcing a recall. Just a slow, steady erosion of customer trust and brand reputation that happens one disappointed buyer at a time. But the pattern it establishes becomes GM's playbook for the entire 1980s. And that's where this story stops being about exhaust manifolds and starts being about the death of American automotive excellence. Cost-cutting becomes the primary metric for success. Not quality, not innovation, not customer satisfaction. Just cost per unit and quarterly profit margins. Engineering excellence becomes secondary to making the numbers work for the next shareholder meeting. The accountants win every argument, and the engineers learn to shut up or find work elsewhere. This same thinking, this same corporate philosophy that said $17 per car was worth sacrificing performance, it metastasizes through the entire company. It becomes the answer to every question. How do we compete with imports? Cut costs. How do we improve profits? Cut costs. How do we meet emission standards? Cut costs. Everything becomes about doing things cheaper instead of doing things better. This same thinking leads to the Citation front-wheel drive disaster, where GM rushes a fundamentally flawed product to market to save development costs and beat Ford to the front-drive compact segment. The Citation launches in 1979 as Motor Trend's Car of the Year, and within 2 years becomes synonymous with unreliability, with brakes that fail, with engines that die, with transmissions that grenade themselves. GM sells 400,000 Citations in year one and watches their reputation crater as those 400,000 cars all break in spectacular fashion. It leads to the diesel engine catastrophe, where GM tries to cheap out on diesel development by converting their gasoline V8 diesel. Instead of engineering a proper diesel from scratch, they strengthen a few internal components, change the compression ratio, bolt on a diesel fuel system, and call it good. The engines fail catastrophically, heads cracking, blocks cracking, fuel systems clogging. GM ends up destroying the reputation of diesel passenger cars in America for an entire generation. Even today, Americans are suspicious of diesel cars because of what GM did in the early 1980s. It leads to parts bin engineering, where the same mediocre components get shared across multiple divisions, eliminating the character and uniqueness that made people loyal to specific brands. Why buy a Buick if it's just a Chevrolet with a different grille? Why pay Cadillac prices for an Oldsmobile with leather seats? The brand differentiation that GM spent decades building gets sacrificed for inventory efficiency and component commonality. The import brands capitalize on GM's decline with surgical precision. Honda builds the Accord into America's best-selling car by focusing on quality and engineering integrity instead of quarterly profit optimization. Toyota builds a reputation for reliability that GM can't touch, can't match, can't even comprehend. These companies are playing a different game. They're building customer loyalty for decades, not quarterly returns for shareholders. Even Ford, GM's longtime domestic rival, starts eating GM's lunch by simply not making the same cost-cutting mistakes, by actually listening to their engineers occasionally. The emissions angle makes everything worse and creates this beautiful irony that the accountants never saw coming. The stamped steel manifolds don't just hurt performance, they complicate emissions compliance. The reduced exhaust gas temperature affects catalytic converter efficiency because cats need heat to work properly. The warping and cracking creates vacuum leaks that mess with air-fuel ratios and confuse the primitive computer controls these cars are using. GM ends up spending more money on emissions-related warranty claims than they saved on manufacturing the damn manifolds in the first place. The cost savings evaporate into warranty repairs and customer dissatisfaction. Engineering credibility evaporates like water on a hot manifold. Ironic, right? The talented engineers who built GM's reputation in the 50s and 60s, the guys who designed the small block Chevy and the turbo Hydra-Matic, and all the innovations that made GM dominant, they start leaving for other companies or retiring early in disgust. The new generation of engineers learns that their input doesn't matter if it conflicts with the finance department's goals. Why bother innovating when innovation gets shot down in favor of cost savings? Why develop better solutions when cheaper solutions always win approval? Innovation suffers. Quality suffers. The products suffer. The customers suffer. By the late 1980s, GM's market share is in free fall. The company that once commanded 50% of the American automotive market is down to 35% and dropping. The company that once dominated American automotive industry with products people actually wanted is bleeding customers and profits. And while you can't pin all of that on stamped steel exhaust manifolds, you also can't separate the manifold decision from the corporate culture that made it possible. A culture that valued short-term savings over long-term excellence. A culture that forgot what made them great in the first place. The lesson Detroit refused to learn. Here's what kills me about this story. It was completely avoidable. GM had a working solution. Cast iron exhaust manifolds were proven technology. They didn't need fixing. The $17 cost savings per vehicle wasn't going to make or break the company. But the decision to prioritize short-term profit over long-term product quality revealed something fundamental about GM's values. And the pattern repeated. Throughout the 1980s and into the 90s, GM kept making the same mistakes. Cut costs, compromise quality, lose customers, lose market share. The manifold decision was just an early warning sign that nobody at GM wanted to acknowledge. Other divisions followed the same playbooks. Pontiac, Oldsmobile, Buick. They all started getting cost-reduced components that hurt their products. The accountants were running the asylum, and the engineers had no power to stop them. You want to know why GM had to get bailed out by the government in 2008? The seeds were planted in decisions like the stamped manifold switch in 1981. Every time GM chose quarterly profits over product excellence, they lost a little bit of customer loyalty. Every time they gimped their products to save a few dollars, they gave customers a reason to consider the competition. The manifold story matters because it's a perfect microcosm of everything wrong with American corporate thinking in the late 20th century. Optimize for the wrong metrics, ignore the feedback from people who actually understand the product, prioritize shareholder value over customer value, and then act surprised when the whole thing falls apart. There's a reason the aftermarket exists. It's to fix the problems that manufacturers create when they forget that building good products is more important than maximizing quarterly earnings. The fact that GM customers had to immediately spend hundreds of dollars to make their new cars perform properly should have been a massive red flag. Instead, it became standard operating procedure, and that's the real tragedy. GM had the knowledge, the expertise, and the resources to build world-class vehicles. They chose not to. They chose cost-cutting over excellence. They chose quarterly profits over long-term brand health. And they paid the price for decades afterward. The stamped steel exhaust manifolds are still out there, on millions of GM vehicles from the 80s and 90s. Most of them have been replaced by now, either with aftermarket headers or with factory replacements that still suck just slightly less than the originals. But they stand as a monument to a decision that never should have been made. Sometimes the quiet changes are the most destructive. No press releases, no fanfare, just a slow degradation of quality that customers notice but can't quite articulate. That's what GM did with these manifolds. They thought nobody would notice. They were wrong.